Hello friends, we will see the second part of resistance training together. The terms pull up and pull down in electronic circuits. At the input of the circuit sections, such as the input of ICs or the input of microcontrollers, we usually design our circuits as pull up or pull down in order not to create a disturbance on their input. Okay, how is pull up? Suppose this input is a microcontroller and it is supposed to be stimulated by the current. In the initial state, we always connect this to the positive voltage level of the circuit with a resistor, which is usually a large number like here, 10 kilo ohms. And when the microcontroller is turned on, the voltage level here is always 5 volts. Because with this connection, it is connected to this positive voltage, and if the voltage is positive 5 volts, no noise or disturbance will occur on the micro. If we are going to apply an input and activated that input, that is activated it, like here, we put a push button here and our input is activated. This is explanation of the pull-up circuit. Okay, we have the same things in pull-down. How it is? We connected it to the ground with a resistor, and the input logic of our IC is always ground. And if we have to give a command, we have to connect it to our positive voltage level. In this way, this is a microcontroller. Its input is always up, and when it is supposed to be activated, we give it 5 volts with a switch. If we disconnect the connection again, the logic is clear that it is the ground. We call this circuit pull down. Next, I want to talk about specific resistances. I will introduce special resistances in 4 categories. 1. Thermistor or thermal resistances. Temperature resistors that are either NTC or PTC. 3. VDRs and PPTC. And 4. LDRs. Thermistor resistors are variable resistors with temperature, and it can be said that is a temperature measuring sensor. These resistors are used to measure temperature. They have 2 models, either NTC or PTC. NTC becomes negative thermal coefficient, and PTC stands for positive thermal coefficient. Okay, how does an NTC thermistor work? According to the diagram here, it is clear that as the temperature increases, the resistance of these NTC piece decreases. That is, in the first stage, its resistance is very high. As the temperature increases, this resistance decreases. And it has a relationship, and its relationship is not linear but logarithmic. But it is used to measure temperature. Its schematic view is usually a variable resistance, where a T degrees and a negative sign are placed. Okay, well, NTCs are PTCs in their reverse state. PTCs are positive, which means that as the temperature increases, our resistance increases. And again, this is logarithmic and does not have a linear relationship. Its different models are the same as NTCs, but their colors are different, and its schematic view is a variable resistance and T, degree, and positive symbols. Now, how can we use thermistors in the circuit? There are 2 circuits that are most used in thermistors, or in the form of resistance division, where two resistors are placed. Suppose the thermistor's initial resistance is 10 kilo ohms. We will also put a 10 kilo ohm resistor here, and the voltage considered here, we get that the voltage is this. Normally the output here is halved at the temperature of the environment, because the two resistances are equal, and the higher the temperature, the warmer the environment becomes. That is, the less output we have here, the higher the temperature. If it is PTC, it is the opposite. As the temperature increases, our voltage here also increases, and this voltage measurement gives us the temperature. A more accurate circuit that we can be more accurate is resistance bridge circuits. Usually we put 4 resistors, 2 ends of each were positive with the same voltage, and the 2 sides of the ground voltage, and we measure the potential difference between these 2 resistors. Again, suppose, for example, these resistance and NTC are 10 kilo ohms. We have 4 10 kilo ohms resistors, and we keep 3 to 10 kilo ohm fixed, and the output here is 0 in the first state. Because the voltage is halved here, there is also a resistance division with 0 potential difference. The higher the temperature goes, if it is NTC, the resistance will be lower, and finally our potential difference will increase and we can measure the temperature. Which are 2 very common applications in electric motors, where the NTC is placed on the motor coil in different places, and when a large load is created on the motor and the motor consumes a lot of current. Before damage to the coils, when the motor reaches this resistance, it measures the temperature and commands a thermal switch inside the motor to stop the motor. In electronic boards, for example, a computer board, which here is a CPU, and this metal piece is a heatsink that exchanges the temperature with the environment. And a PTC or NTC piece is placed below this, and the resistance measurement, this part, gives us the temperature of the heatsink. The next model of special resistors are VDRs. VDRs or Varistors, their main job is voltage protection. We can see the performance diagram of a VDR. As you can see, the current passing through a PTC to a specific 0 voltage, it is open circuit and its resistance is very high and up to a certain voltage value. Its resistance is infinite and no current passes through it. At a higher voltage level, the resistance suddenly decreases and it seems like a short circuit and the current is very high. It passes through it and it is called the breakdown voltage, which is the protection voltage of our circuit. Its symbol is also specified in this way in the schematic circuit, and it has different dimensions and ranges for different applications, and they are usually determined by their breakdown voltage. Okay, here I want to explain how voltage protection is done. Look, this is an electronic board that we want to do voltage protection on. Suppose our input is 24 volts. We put a PTC whose breakdown voltage is, for example, 36 volts and is higher than the input voltage. Parallel to this, if we connect the voltage here to 24 volts, because before this breakdown voltage there is no current from it, doesn't pass here, and the device turns on completely and has its normal function. But if a large voltage, for example 220 volts, is connected here by mistake, in an instant its resistance becomes infinite because it is higher than its breakdown voltage, and the current, instead of, if it wants to pass through this circuit and our circuit is damaged, it will pass through these and this part will burn. Different part numbers have different codes. There is a standard code on each of them, which are identified based on that code. In this figure, for example, this is 680 or this is 820, which is their breakdown voltage. And there is no difference in alternating current and constant current. VDRs protected the circuit against overvoltage, but PPTCs protected the circuit against overcurrent. Okay, we said that the main function of resistors is to limit the current, and that current is lost in the form of temperature to the environment. PPTC also has the same function, that is, when the current passing through it exceeds its specified limit, its resistance increases and it operates as an open circuit and does not allow the circuit to consume current. And as soon as the current is cut off, its temperature gradually decreases. It gets cold and its resistance becomes zero. There are different models that are determined based on voltage and current. That is, how much current can pass at a certain voltage. And it's not like a fuse. A fuse is not reversible when it operates, but PPTC is reversible if that factor which causes an additional current to it performs its function correctly again. At the entrance, we said that there is a VDR. After the VDR, it is placed in series with the PPTC circuit itself. And the last part, which are LDRs. LDRs are also variable resistances with light. LDRs have fixed resistances that measure ambient light with lux. As the ambient light increases, its lux value increases and the LDR resistance decreases. And from this decrease in resistance, we can measure the intensity of the ambient light. Okay, in this video I try to explain all resistances to you. Be successful and victorious.